have our next bio break, we will have another really exciting talk. And I know we all need another coffee, but stay tuned now. We will talk about responsible AI, as I mentioned beforehand, and the road to carbon neutrality. And this time, it's exciting because we have two speakers here, and I would like to ask you to come on stage.
The talk, I will tell you something about the general approach of Cityf to AI and machine learning with a special use case of recommendations. So maybe you know Cityf, the Zweite Deutsche Fernsehen. Yesterday I was at a speaker's dinner, and not everybody under 30 was aware of that there's a channel in Germany that sends linear TV. So I just want to emphasize that. So besides linear TV, we obviously have Cityf Mediatek, that is our streaming service that is quite successful in Germany, where we have a full program. And I would like to emphasize that, you see it here on the right side on the screen, that a lot of the content on the start page is generated by algorithms, obviously. So when we start with a stage teaser and also the next content cluster, that is all run by algorithms right now. Overall, that generates roughly about 50% of the viewing volume that comes from the start page, so very important. And what's also really interesting, and that's important to us as a public service media broadcaster, is that we have 20% of all the content that is available within Mediatek, and there are a lot of content available, are recommended and used each day. And that is, of course, magnitudes more than some editors could do it in the manual fashion. Very interesting. Especially important is recommendations on smart TV, on the big screen, where you just don't want to interact with the controller more than ever needed. So very important on that. But there we don't want to stop. We want to go further and further personalize and automate the Cityf Mediatek. And that's a very important point here. We do this according to our public service media remit, and that is some kind of regulation. You heard about this topic all the day. And before we go into the details, I would like to highlight that we built up a team for that. That is the personalization automation team at Cityf. We built up that team since 2018, roughly. The people there have a very different background. So we have editors in there. We have also data engineers, data scientists in here in different roles. Those people are running the service itself. Right now, it's a multi-client service, so the R&D is also using that service, also some kind of sustainability. And we also develop our own algorithms. And what's interesting, the background of the different people I just mentioned, we have also people with a background in nuclear physics and who are really strong in statistics, for example. And these people are really determined and have really the public service media at their hearts. And they are facing some really interesting challenges I want to highlight right now. So when you start with the public service media remit that is encoded in law and paragraphs, so a lot of text, and you just look down vertically to the algorithms where you have code and data, it's obviously not so easy to tell if there's a really correlation or some kind of alignment. And what that makes even more complicated is that you have different distinct layers of people and communication standards where you have a common sense. For example, talking about the PSMR, that is the domain, of course, of our boards and regulators. We have a lot of them. That's good, of course. We have the editors who are in charge of doing the right thing on the website. And they're talking about these PSM values like impartiality, transparency, and all that stuff. And on the other hand, on the lowest level here, we have, of course, the data scientists, the machine learning engineers, and all people handling code and data. And they're thinking about something completely different. They are talking about information retrieval metrics like mean reciprocal rank, non-discounted cumulative gain, hit rate. And that is really kind of a problem. And back in 2018, when we started this personalization thing, we had to invent some concept how to bridge things. And that is what we put up as a concept here, is that we said, okay, we have to bridge that, and so we have to develop our own metrics, so the PSM metrics, especially to address the effects of recommendations when it comes to the audience, most important for us, of course, and the content partners. We have a lot of content partners right now. We have nearly all the R&D content within Cityf Mediatek right now. And we put up them. So they are based on some really established metrics, like, for example, coverage. So how much do we use of the catalog, novelty, how often do we have niche content available? That is really important to us. And of course, diversity. Diversity, when we mentioned that, is, of course, it's kind of a family of metrics. So diversity has a lot of different detailed definitions. And the most important one is for us, of course, serendipity. So we want to bring users to use different content on different topics, and that is something that is deeply within the mindset of the public service media, especially. So we set up that, and something that is also now a DNA is transparency, obviously. So we said, okay, we got this concept, now we have to talk to the people and bring that into the public. We set up a website, Algorithmen.ctfd, where we explain all the use cases. So we tell, okay, this part of the Mediatek is automated or personalized. We use this algorithms. We have made that decision. That is the KPI in the special use case here. And we also deal really openly with our own limitation and weaknesses. So for example, we got a lot of bias in our data. So we got a lot of problems here. But that's really important to address them openly and get back with feedback and improving on that. So that is not the idea. We tell you what is right and wrong, and we are the best ones. It's more like, okay, that is our current approach. If you have something we can improve, just tell us. Also, this is, I think, a step before the next step we are planning right now. So the next step would be for us open sourcing all the code we have, so the code bases, and especially the algorithms. Why haven't we done it the other way around? Because we think it's really important to have a conceptual framework, what we try to achieve with those algorithms. And just handing all the algorithms is not so interesting at all. Yes, and of course, transparency is the basis for an informed discussion. We were hoping for a lot of feedback. Now I can tell you we got, since we launched that in November, I think, 10 emails. So 10 people, half of them said, I'm clever enough, I don't need algorithms, I can search for myself. Okay, that's fine. That's also fine for us, obviously. You can just switch off personalization completely within Cityf Mediatek. But we also got some really valuable feedback and interesting discussions here. What we also have there is a bit more data and a bit more technology. So one really interesting problem is when you learn from past data that you have biased data in. So there's some hero content that's used much more than other content. And there is a lot of papers around there where there were developed countermeasures. And this is a paper that was published last year on the ASM Praxis. And we just put that paper, and it has a really nice approach because you just have to adjust your evaluation function. There's a term you can bring into your elevation function, and then things go better. And we tested that. And the right side you can see, and that is also online available, what that result brought to us. So you can see here on the right side, we have an A/B testing running all the time. And within the debiased group C, you can see there is a lot less popular content recommended. That's really great. That's the goal we try to achieve. But also, and that's also really interesting for us, that we have no decrease in viewing volume, but we see an increase in viewing volume. So people really think it's a great thing that we don't have just really popular content, because those recommendations are more tailored to the specific interests of the users and not just what nearly all or everybody really likes to see. So also very interesting. Now let's go a bit deeper into the sustainability thing. Carbon neutrality is our sustainability goal #1 overall. When it comes to recommendation algorithms, we back in 2021 had a talk and paper at the Rexus conference, and we coined the term green recommendations. That means where can we save energy in the different parts of a recommender system. And there are obviously some ways to do it. Something we have just already done, for example, using shallow models is really a means of using much less energy. Of course, using less data is always interesting. We were also deeply into online training. So for example, we are using within the stage teaser reinforcement learning, where you're just going to learn a probability distribution of your content in online fashion, and you don't have this really high volume, high GPU loaded retraining and batches from past data. Also in the stage teaser, we have user segments. So we first started in a lot of use cases with hyper individualized recommendations for a specific user with a very, very specific viewing history. He got us really special and individual recommendations, but we found out that in some use cases it's good enough. I'm interested in discussion what that means in detail, but it's good enough to just recommend on user segments. So you're also saving a lot of energy and costs. And that is for the training and the algorithm part, but also within the inference, of course, caching really plays a big role. Also, adaptive-free computations, really heavy computations you can do when you load on the GPUs is not so high, actually. And also, again, there's the idea that maybe user segments can be more power efficient and lead to comparable results. So this is more like a broad overview. The next part, Leif will tell you about some experience we run also. So.
All right. Thanks a lot, Andreas. So yeah, indeed, we have been.
The big one.
All right. Yeah. So I would like to tell you a bit more what we did concretely together with Cityf in an experiment. We are Xayn. We're a research-based startup. We focus on green AI and more precisely on personalized semantic search and recommendation. So our DNA is also transparency, sustainability, and also privacy. And I will also go a bit deeper into how this approach works for us. So first of all, we actually focus on language models. Now, of course, we talk today a lot about language models. We talk about mostly large language models. Right? Everybody knows now about GPT, ChatGPT, etc. And those models, of course, are great when it comes to generation of text, when it comes to processing not a lot of data, actually. Right? So we have really big models that are actually suited for not a lot of data. So we actually take another approach. We actually go from big to small so that we can actually really process a lot of data. And with a lot of data, we mean millions of documents or even more. And the second aspect is privacy. And also in privacy, we actually go also the other way around. We go from big to small. So instead of just focusing on all of the user and base and all of the content and transactions that these users process and looking at them at once, we look at them individually. So what we do is actually we build a known model, a language model. It's a small language model, so we actually go from generalization to specialization. We focus on search, as mentioned, and recommendations. And we also focus on distilling this model very specifically to these use cases and making it as small and efficient as possible. I will tell you later about the actual metrics behind that. Well, we even achieved with our system that we can run, for example, these language models, these transformer models, on mobile phones instead of supercomputers that have to be developed now. So it's really suited for processing a lot of data. So here's a more concrete example of what this actually means. So on the left side, we compare ADA 2 from OpenAI, which is a comparable model, so you can actually do comparable things. So you can embed a lot of documents with it, and you can, for example, do a similarity search. You can do asymmetric searches, so you can do question answers on a lot of documents, obviously. But if you look at the actual computational power that's needed to process these models, and in comparison, for example, to our model Xayn, then the difference is gigantic, really. So we talk about 98% energy consumption less. And just to have a few hints of what you can actually save with that, You can shave more than 8,000 beards with that. Or for a more Berlin-based example, you can actually run a massage chair for 14 hours straight. So obviously, this energy reduction also relates straight away into cost reduction, right? So obviously, you save CO2, but on the other hand, you save also cost. And cost is, of course, really important when it comes to processing a large number of documents. So this is a customer example from us where we have to process around 80 million documents. And obviously, you need to do this in a very efficient way, otherwise no one will actually use it in production. And we hear this actually a lot when it comes to language models and transformer models and natural language processing. A lot are actually talking about it. A lot are playing around with ChatGPT, with GPT-4, GPT-3, etc. Also BERT models from Google. But no one really uses them in production, only very few, and only for use cases where it doesn't come to a lot of data, a lot of search requests. And also in this example here, we talk about millions of transactions, and the costs are, of course, really important when it comes to production use cases. So we are actually focusing on sustainability, but then actually leading to production cases. Now let's come to Cityf. So what did we do here? So Cityf has, as Andreas introduced to you, the Mediatek. So it's a classical streaming platform. Right? Everybody knows these streaming platforms. You know Netflix, you know Disney. You know how they work. Right? Without recommendations, without personalization, they would almost not be usable because the content base is just too large. Right? So these platforms need to understand the users. These platforms need to understand the content behind them. And one of the main use cases on these platforms, and I think pretty much everybody of us here has experienced this use case, I would even say 100% of you, is a lean-back scenario. So you watch something, and it recommends to you the next content. It's a very, very classical use case. Now, of course, Cityf Mediatek as a streaming platform also has to serve this use case, right? I mean, you have to compete against the other streaming platforms. You have to be modern. You have to really also innovate, but also you have to really use the same technologies, right? Now, also here in this use case, Cityf recommends the next video. And as Andreas mentioned already, they do this already in a very, efficient way. Efficient in a way that they use rule-based systems for watching, for example, a series, right? If you watch a series, you likely want to watch the next episode when you finish the first one, right? So you don't need AI for that. But when it comes to, for example, let's say a movie, a documentary, whatever, then actually they use their own models that they developed. And in this case, Andreas already mentioned, they're trying to be as data efficient as possible. They only retrain incrementally. They don't retrain all the time. And of course, by that, also save cost and save energy. However, let's come to what else you can do for energy saving. So as mentioned, Cityf developed a sequential model for this, which is really highly adaptive to the user behavior, right? So it uses the user interactions, it uses the content, and it's trained on this data, right? So it's a very specialized model. Now let's switch this out with a zero-shot model. So we did that, and we used our system for this, and we achieved a similar click rate, although not having seen the content before, right? So not having knowledge about the user, not really training on the users before, and applying this completely zero-shot. And this is actually really impressive because this is a model that is generated and was trained on data that we actually just got from the internet, right? So we don't even know, and of course we don't have just access to all of the Cityf users, right? So we do this in a privacy-preserving way. We don't want to have this data. And so this is a pretty impressive result, but let's wait for the next result. We actually measured also the energy consumption that's necessary and the computing power that's necessary to actually realize this use case. And we saw that our system consumes 98% less energy than the sequential model that was trained from Cityf. So we think that this result speaks for itself, and it should also aim at taking away the fear. And we just talked about fear in the last talk, right? Talked about fear of applying this, right? And fear is not only about what can the AI do, but we always see that companies fear the cost, right? Because, well, AI, well, you don't know what it will cost you at the end, right? So we hear that these models are too big, they're too complex, etc. It will cost us millions. But actually, we see here that we can actually really work on the algorithms themselves and bring just better results, bring more resource-efficient results. And another remark to this, I always hear that all these kind of legal constraints in Europe, all this kind of focusing on privacy, right? I mean, we heard about GDPR, etc., that this is like going against innovation, right? And also another point, Europe doesn't have access to this large amount of data that, for example, China or the US has. Of course, that's true, but I really believe that actually this kind of constraint of not having enough data, having all this regulation, is actually innovation-friendly on the other side as well, because we have to really think about those systems. We can't just like throw data on some simple decision trees and still produce good results. We actually have to think about really deeply, well, how can we produce better models? How can we produce better systems? It's also not only about the AI, it's about the system behind it, right? And so we really believe that Europe can also go its own path, and we can actually really develop own systems that are actually inside more clever, because we just have to be more clever. We have to work harder, and I think that this actually can also drive innovation. So what are the next steps? So we will go further and analyze the data. We want to also change a few things and see whether we can do even better than this. We want to experiment with different hardware and algorithm setups and see what else we can do. And we will also prepare a paper and submit this, and also want to, of course, see what other researchers, what the community thinks about these approaches. Thank you very much.
Andreas, Leif, great successes you celebrate here from the energy consumption side. We all know data is always in the center of everything, and when we could exclude this privacy part, I think we would grow so much faster. What I would be interested in is how do you see the user experiences with AI in 10 years?
Oh, well, 10 years is really far away, right?
Yeah.
So currently, we think the next big step for us is to fully automate and personalize the Mediatek. Of course, there will always be points where the editors say, okay, there's an event going on, sports polls, for example, so we have that. But that will be a conversational AI, for example. I really strongly believe in that. Or what role these own platforms will play, so it's really hard to foresee. I think with the next 2 or 3 years, we'll see more personalization, more automation, and we will see, of course, generative AI coming into play. So, for example, there are also some use cases where you can use explainability of those generative models. So I think, 2 or 3 years, you have some idea. 10 years, I'm really sorry.
Yeah, it's so far away, right? What do you think about AI chatbots or AI virtual avatars?
Well, I think, they just will belong to the future, right? Of course, people probably will just learn how to interact with them, and of course, we see like a big enthusiasm right now, but I think it will just become normality, right? So.
Yeah, and how can we solve the problem with lack of data and also maybe not so clean data? What do you think?
Yeah, I think it's really interesting to think about the minimum amount of data we use for the use case at hand. So I don't want to ask people for data when I cannot bring them back some value, and it's really an open, complex question what the right amount of data for our use cases is right now. Maybe in personalized medicine, for example, that's really another point, another discussion. But we have seen that we, in most cases, don't need this really highly individual personalization. So I think looking for the minimum amount of data and the simplest algorithms is really a way to go for us within that use case.
Yeah. Have you thought about closing these gaps with AI also? And I mean, there is also the option to forecast maybe new data and the development of, for example, user experiences?
Yes, of course. Synthetic data is really right now in production. We use that to get some distributions of specific data that also helps with some privacy issues. Of course, you don't have to use data from the people outside there. Really interesting for us. Yeah, that's quite normal, I would say. Yes. And the other use cases, I'm not so sure about that. Yeah. So we will move a bit slowly because we are really in a constrained domain. We have really a lot of regulation. And bringing that into production was really hard work. So I think, we have to gather some feedback on that and try to explain to the people what we're doing. Yeah.
Really interesting. You want to mention anything else?
Yeah, actually, I wanted to say that coming back really to the cleverness and how you actually do this, right? I mean, for example, in our case, it's pretty interesting because we just, for privacy reasons also, we just can't look at all the users at the same time, right? And do cross-user referencing and so on, which you can see, of course, in other platforms. And 2 points that are important here. First point, we also see studies where people actually don't really like this so much, right? It doesn't really help in the adoption. So that, for example, let's say, coming back to the Mediatek, just because the majority of people watches football right now, you recommend also football, right? And maybe just because you look similar from your profile, you get also some other recommendations from other users just because you did something, right? So looking at the users from an individual perspective and just recommending based on their interactions is actually also something that can help really in the reducing also the risk and reducing the fear of people. And for example, of course, what arises then is the cold start problem, right? I mean, you have to start somewhere and you have to really rapidly learn. And this is, of course, where, for example, what we do, like with really kind of looking at the user like from a mathematical view that you can really picture the user in the embedding space and really very rapidly learn what the user might like and not like is something that actually can help you also with the cold start problem. And you just have to focus on solving this problem in a more clever way, right? If you don't have the data at hand.
So one last sentence. The future of user experiences is, in one sentence?
It will be personalized, I think.
Okay, and for you?
Fully personalized, of course.
Okay, so you're aligned. Great, thank you.
Thanks a lot.